25, 26, and 27 are some word problems. Remember, in our notes for vectors, we looked at 2 different ways to do the word problems like this. When you're looking for a resultant vector, you could physically draw the addition tip to tail method or triangle method, creating a triangle using law of sines and cosines. Or then in part 4, we looked at component form. And we said, okay, well, you can put the vectors in component form and use a more algebraic approach. And so I think most people probably prefer the latter, the algebraic approach in component form. So that's how I'm going to go through solving these. If you prefer the other method, you can do it that way, and your answer should come out the same as mine. Okay, if it's not, you're doing something wrong, and maybe you should switch to this method if you don't understand the other method. Okay, so in this one, we are told that a helicopter is moving at a 75-degree angle with the horizontal at 52 kilometers per hour, and a 30 kilometer per hour wind is blowing at a 20-degree angle with the horizontal. So luckily, both the angles are given from the horizontal, so there's no converting the angles necessary. It's not a quadrant or true bearing given. Okay, so this is the first vector, is the actual helicopter's heading. And then the second vector is the wind. And we want to know the resulting velocity and direction. So we want the resultant vector. Okay, so remember, so step 1 is put them in component form. Okay, staple it to the page. All right, when you know the magnitude and direction of a vector, we do the magnitude times cosine of theta and the magnitude times sine of theta. Okay, and that's going to give us our component form, our horizontal component and our vertical component. Okay, so for the first vector, that would be 52 times cosine of 75 and 52 times sine of 75. For the second vector, that would be 30 cosine of 20 and 30 sine of 20. You'll enter these into your calculator. Make sure your calculator's in degree mode. The calculator built into the test on Aware is very similar to the Desmos calculator. It looks real like the same operations. Okay, so 52 and 75. So 52 cosine of 75, 52 sine of 75, and then 30 cosine of 20, and 30 sine of 20. Okay, so I've got the horizontal and vertical components of both of those vectors now. I don't know why the 52 cut off, but whatever. All right, so rounded, that is 13.46 and 50.23. And the second vector, the wind, is 28.19 and 10.26. So component form, done, check. We got both vectors in component form. Step 2 is to add them to get the resultant, because a resultant vector is the sum of 2 vectors. So I'm going to add those 2 vectors together. When you add vectors, you add the horizontal components together, you add the vertical components together. I don't want the rounded values. I'm going to use the whole big values from the calculator. So I'm going to add this horizontal one plus this horizontal one. And then I'm going to do the same thing for the vertical components. This one plus this one. In the Friday folder. All right, so when I add those together, I get 41.65 and 60.49. But I want to keep those big long decimals in there to use when I find the magnitude and direction. Okay, so step 3, the magnitude, remember, is found by doing the square root of a squared plus b squared. So that's my A and that's my B. Okay, so in my calculator, I'm going to do the square root. Well, I don't know why I went there. Try that again. Square root of A squared plus B squared. And notice I didn't square the rounded values. I squared the whole big long numbers. And that came out, I'm not even going to write all that down. Y'all can see it in the calculator there. This is what I did. When we give our sides, I'm having y'all round to hundredths, so 73.44 for our magnitudes to hundredths. That is representing kilometers per hour. Okay, that is the speed. Okay, so that's the magnitude. And then last but not least, the direction. The direction uses inverse tangent. Remember, it is inverse tangent of B over A. Okay, of those numbers again from the resultant vector. So second tangent, and the B was the 60 number divided by 31. Copy that over. And we give our angle to the nearest degree. So about 55 degrees. And that's the direction angle, the angle with the horizontal. Does that make sense? If both vectors were positive horizontal and vertical components, that means to the right and up, to the right and up. Doesn't it make sense the resultant would be in quadrant 1, to the right and up? Yes? Okay. Because sometimes when you do that inverse tangent, this angle may come out different in a different quadrant than where your vector is showing. And you may have to like add 100, it may be the opposite direction. You might have to add 180 degrees to it or something like that, depending, because like tangent is negative in quadrants 2 and 4. Tangent is positive in quadrants 1 and 3. So had your vector been in quadrant 3, it would have given you the same 55 degrees and you would have had to realize, wait, it's supposed to be quadrant 3. So it's not 55 degrees. I need to add 180 to that to get to quadrant 3. Okay, so just pay attention to what quadrant your vector would end up in standard position. Okay, you all good with that one? All right, let's look at the next one. Ryan, what do you need, babe? Okay, well, yeah, I'm recording right now, so. You wanting multiple choice or FRQ? Is this one yours? Doesn't have a name. Okay. All right, so looking at 26, our first vector is a canoe going east at 4 miles per hour. Okay, so that's the heading of where it's being paddled. But the river is flowing southeast, -10 degrees with the horizontal at 1.5 miles per hour. So those are the two given vectors. We want the resulting speed and direction. Okay, so again, same process. So first component form. Okay, so for the first vector, the magnitude is 4. What is the direction if you're going east? What is the direction in degrees as a angle with the horizontal? Say it again. 0. Good. Okay, so that's 0 degrees for theta. So for cosine of 0 and for sine of 0, because you're going to the east, so if you think about your XY axis, east is to the right, so you're at 0 degrees. All right, now hopefully y'all can do this one without a calculator. Since 0 degrees, you should know that from your unit circle. So cosine is 1, so that would be 4. Sine is 0, so that comes out to 0. So that's the vector representing the paddling, the canoe being paddled. And then the second vector, the magnitude is 1.5, and the direction is -10. Now you can put a negative degree because it tells you it's the angle with the horizontal. So it's fine to have it as -10. If you prefer to have it as a positive angle, when you give your final answer, you would want it as a positive angle. So if you want to convert that to 350 degrees, that's fine. But you can enter it as -10, and it will give you the same answer. All right, so when we calculate this one, this over. That's not what I meant to do. Okay, so when we calculate this, 1.5 cosine of -10 and 1.5 sine of -10. So 1.48 and -0.26. And then step 2 is to add those two vectors to get the resultant. Okay, so that is the resultant vector in component form. They want both the magnitude and the direction. So remember, the magnitude is the square root of a squared plus b squared. So remember, when I go to plug this in, I need to add 4 to that number because I want the entire big decimal in there. Okay, so now that's my A and B. Okay, so I'm going to do the square root of a squared plus. Now I need to enter this one because it's negative in parentheses. Squared. Okay, and that comes out to 5.48. I didn't copy over the rest of that. Let me copy this real fast. Okay. So the magnitude, we're going to round to hundredths. So 5.48, and that is representing miles per hour. And then finally, step 4 to get your direction angle. we're going to do inverse tangent of B over A. So that is second tangent. There's B over A. All right, so that comes out, this is one where it comes out negative. So we're going to ask ourselves, does that make sense that the angle is negative? Is that negative 3 degrees approximately? Would be in quadrant 4. Look at the vectors in component form. It's positive, negative. Is that quadrant 4? Yeah, so that makes sense that it's negative 3, so that's fine. It's the correct quadrant, but they're probably going to ask you to give it as a positive angle. So we would actually add 360 to that. So that is 357 degrees with the horizontal. If you left it as negative 3, I mean, that's acceptable too. If it was a multiple choice question, you just have to look at how the answer choices were written. Okay, but that is your magnitude, the speed, and the direction of the boat. You all right with that? All right, last but not least, last one. So the first vector is Connor walking 45 kilometers north. And the second vector is 80 kilometers west. So north and then west, that's going to make a right angle, isn't it? So this one's actually going to form a right triangle. These are actually a little simpler because you'll work better with right triangles than oblique triangles. Okay, it says, in what direction and how far must Connor travel to make it back to his home? So this one, you can do what we did on the last two. You can put them in component form, do the 4-step process, but this one I'm actually going to draw out because it's pretty simple. So north, 45, west, 80. We're looking for the resultant here. Okay. Now, right triangle. I know 2 sides. How do I find the third? Okay. Okay, it's the square root of a squared plus b squared, right? Okay, a is the horizontal component and b is the vertical component, right? Now, this ends up being in quadrant 2. So this is actually a negative horizontal movement. It's because it's to the left. So when we square it, it doesn't matter. So we square the negative, it comes out positive anyway. But when we do our direction angle, that's going to make a difference. So 80 squared and 45 squared, take the square root. All right, so that's 91.79 for the distance. So that was in kilometers. Now here's where it may get a little tricky for this one. It says, so he walks north and then west, and he wakes up astonished. How far and in what direction must Connor travel to make it back to his home? So we actually, that is the resultant vector is going this way, but I actually want to know this direction going this way, don't I? To get back home, doesn't the arrow need to go this way? Do y'all understand that? Okay, so when we find the angle, okay, if you think of this as the XY axis, when we find this angle, we actually need the opposite of it. So when we find that angle, we actually have to add 180 to it for it to go this way. Does that make sense? Okay, so to find the angle in the triangle, we use tangent, opposite and adjacent, okay? Or you can consider that your A and your B. As we know, theta, the direction angle, and that's for the direction angle, is inverse tangent of B over A. So in this case, that's negative 80, or excuse me, 45 is the B. So 45 over negative 80. A is the horizontal, B is the vertical. I know that looks confusing because that was labeled O and A, but we're talking about the angle to go home. So this angle up here, so this is opposite adjacent. So I'm not even going to label it in the picture because that made it look confusing. All right, so just knowing that's A, our horizontal, that's B, our vertical. So inverse tangent of 45 over negative 80. Now they actually give us the angle in quadrant 4, don't they? Anybody? Okay, negative 29 is actually down here, right? So as a direction angle with the horizontal, you could tell me negative 29 degrees, but in the positive direction, if you give that to me in the positive direction, you would add 360 to that. So you can leave it there as negative 29, or you can give it to me as 331. All right. Okay.